In the earlier video, uh, I developed the sine curve and I draw the tangent lines to the curve, which are theoretically f prime of x cosine of x. And we see here that the tangent line is parallel to x-axis when the x is pi by 2. And similarly, if I set this one, it's meant to 3 times pi by 2. So this is a tangent line right here. So I started earlier with the 2 points PQ, which uh, theoretically represents the secant to the curve. However, when the h is very small, so the slope of the secant line uh, is equivalent, it becomes equivalent to the derivative or the slope of tangent line. We clearly see here that at this point, the tangent is below the curve, and at the earlier point was pi by 2. It is the point here, it is the tangent line is above the curve, uh, and it marks the maximum of the sine of x curve. So it means in between this pi by 2 and 3 pi by 2, there is going to be a point where the tangent lines have changed their position from above the curve to below the curve. So this is known as the concavity of the curve, which is apparent from the second derivative. And if the second derivative is at some point equal to 0, then it means that is the point of inflection where the concavity of the curve has changed. So with these numerical calculations and the graph, let's get to that point. So theoretically, the second derivative of sine of x is minus sine of x. And if we set that equal to 0, this point is clearly the point where x is pi, which is somewhere 3.1415. So if I set that equal to pi, so the tangent line appears here, and the slope is negative. So let's see the position of tangent before this point and after this point. So I start some tangents like at 2.8. So it seems the tangent line is above the curve. We can recognize the portion of the curve sine of x under this curve from here and also from here. And if I see that one, a point which is after x equal to pi 3.2. So now it seems that it is getting below the curve. So similarly at point 3.4, it is now again getting below the curve. So then at 3.6, yes, now it becomes clear that the portion of curve seems to be above the curve. And as we go further, it becomes clear and clear 3.8. And then at 4.0, as it's much more visible than earlier, that the tangents have clearly gone below the curve. So the point, uh, as we moved the tangent on the curve, so they have changed their position from above the curve before the point 3.14 to below the curve. So the concavity of the curve has changed, and then it goes to the point where the first derivative becomes 0. So that point is 3 times pi by 2. So the tangent becomes horizontal. And before this point, the slope value should be negative, and after that it becomes positive as the orientation of tangent lines are going to change. So if I set that equal to 4.5, 4.5, so I see a negative value of the slope and the curve looking downwards. And then if I go uh, farther from this point, for example, I set 4.8. So the curve seems to have a positive slope. So clearly, between a negative value of the first derivative to a positive value of the derivative, there is a transition from a zero value. So that's the interpretation of first derivative and the second derivative